And now we will take another example of missing readings. We have another one over here. The following data is of a closed traverse. Compute the missing quantities. In this case also, we have two lengths which have not been given, the length AB and the length DA. The angle of AB is 60 degrees, length of BC is 200 meters, the angle WCB is 135 degrees, the length of CD is 600 meters, the whole circle bearing is 200 degrees, the length of DA is unknown, and the whole circle bearing is 340 degrees. As mentioned earlier, the unknown lengths may be because the lengths could not be found out because of some reasons, maybe some obstructions over there, the obstruction in chaining predominantly, because of which the length could not be measured, but the angle could be taken. So we have the angle over here, the length is missing. Another thing which has been already told earlier, which we need to bear in mind, is that whenever we have any missing quantity, there is no closing error. We cannot check for closing error. Okay, so we assume that all the lengths and all the angles have been precisely taken. Okay, the precision has been utmost in this case. So considering this, let us go ahead in trying to find out the two values of lengths. Please also note another thing, we can find maximum of two quantities. Okay, finding third missing quantity is not possible within this procedure. Okay, so let us go ahead. The first step is calculate the latitudes and departures of all the lines. So whatever is unknown, the length L1 and L2 will be assigned to that. So for AB, we will say that the length is L1. For DA, we will say that the length is L2. The length is now known as L1 for AB, and the WCB for AB, the whole circle bearing for AB, is 60 degrees. The latitude calculation, latitude is L cos theta, that is latitude is equal to length into cos theta. For the line AB, length is L1, L1 into cos of 60 degrees. So L1 into cos of 60 degrees gives me the answer latitude is equal to plus 0.50 L1. Coming to departure, departure is length into sine theta. So length of the line AB is L1 into sine of theta, sine of 60 degrees, gives me the answer as plus 0.866 L1. So this tells me that latitude is in the north and departure is in the east because both are positive. Coming to the line BC, the length is 200 meters, the angle is 135 degrees. The latitude is given by the formula length into cos theta. The length is known over here to be 200 and theta is 135. So latitude will be equal to length, that is 200, into cos of 135, which comes to equal to minus 141.42. That means the value of the latitude is minus 141.42, or in other terms we can understand that it is southing of the magnitude 141.42. It is southing because it is negative. Okay, latitude is negative means it is southing of 141.42. Now coming to the departure, departure is given by L sine theta. L is already known over here to be 200 into sine of theta is 135 degrees. So 200 sine of whatever the angle given, 135 degrees, that comes to equal to plus 141.42. Now this tells me that departure is in east direction, or it is easting. Coming to the line CD, CD has a length of 600 meters. The whole circle bearing is 200 degrees. So the latitude can be computed as length into cos theta. So length is 600 into cos of 200 degrees. So the answer is minus 563.82. 600 cos of 200 degrees gives me the answer minus 563.82. Now this tells me that latitude is in the south direction. The projection on the north-south axis is in the south direction. This is southing of 563.82. Southing. latitude equal to minus 563.82. Coming to the departure is L sine theta. L is 600, sine 200 degrees. So that comes to minus 205.21, which tells me that the departure is in the west direction. And the magnitude of the westing 205.21. So this is westing 205.21. Coming to DA, the last line, the closing line, we have unknown, that is L2. The length is L2. The whole circle bearing is 340 degrees. The latitude is L cos theta. L is L2. The length is L2 into cos of 340 degrees. So we get this as plus 0.9397 L2. This tells me that the latitude is in the north direction. The departure, L length into sine theta. Length is L2 into sine of 340 degrees. This gives me the answer as minus 0.342 L2, which means this is in the west direction. This is in the west direction. So now what we have done is we have calculated all the latitudes and departures. Obviously some with the unknowns, but we have computed them in terms of unknowns or in the relative figures. Coming to the next step, step number 2, obtain all the sums of the respective latitudes and the respective departures. Find the sums of the latitudes and that of the departures. So latitude, so we have to add 0.50 L1 minus 141.42 minus 563.82 and then plus 0.9397 L2. So that we have got over here, sum of latitudes is equal to 0.50 L1 minus 141.42 minus 563.82 plus 0.9397 L2. Similarly, sum of departures, the first value 0.866 L1 plus 141.42 minus 205.21 minus 0.342 L2. Putting them together, 0.866 L1 plus 141.42 minus 205.21 minus 0.342 L2. So we have done the second step, obtain the sum of latitudes and that of departures. That is what we have done over here. Going further to step number 3, the sum of the latitudes as well as that of departures should be equal to 0. So latitudes we are putting equal to 0 and then getting the equation. So 0.50 L1 remains over here. The term with L2 also remains over here, that is 0.9397 L2. Now these two terms we have to get together. That will be moving on the other side. That comes to 705.24. That becomes my equation number 1. So we get the equation number 1 as 0.50 L1 plus 0.9397 L2 is equal to 705.24. Coming to equation number 2, the departure has been put equal to 0 and then we are having all the terms. So the variable term, the unknown term 0.866 L1 and minus 0.342 L2 remain over here. These two terms get together, they move on the other side, so we get this as 63.79. So equation number 2 we get from the departure as plus 0.866 L1 minus 0.342 L2 equal to 63.79. So as a result of finding the sum of getting the sum of the latitudes and departures and putting them equal to 0, we get equation number 1, we get equation number 2. Please note, in equation number 1 we have the unknowns L1, L2. Equation number 2 we have unknowns L1, L2. We have two unknowns and we have two equations. So mathematically this can be solved and we can find the two unknowns. Solve the step number 4, solve equation 1 and 2 simultaneously to get the values of L1 and L2. So putting them together over here, obviously that's the simultaneous equation. If we solve this, we get the value of L1 as 587.79 meters and L2 as 305.79 meters. Obviously, this can be solved simultaneously, or we can write 0.5 L1 equal to everything over here and get L1 equal to something, and then substitute over here. We'll get the value of L2, then substitute back to get the value of L1. It can be solved in any of the ways in order to get the value of L1, L2. Okay. Once we get that, we get the value of L1, the unknown which was there. L1, we have got it as 587.79 meters, and L2 305.79 meters. We have found both the unknowns, and that's the way we find them. Okay, thank you.